All right, so we are ready to jump into constructing a confidence interval to estimate a population mean. And the cases we'll consider here are when the population standard deviation sigma is known to us. So I'm going to step through some formulas here and do this in the case of an example, and it will make more sense. So, sorry. Okay, so here we go. All right, so our example, we have an agriculture publication claims that the population mean of the birth weights for all alpine goats is 2.49 kilograms. A veterinary service has hired you to test that claim. So we certainly can't gather data from every single newborn alpine goat. That would not be realistic, but we would like to try to get an understanding of the mean weight. So to investigate, we will take a random sample of 35 alpine goats and record their birth weights. And then it says, assume it's known that the population standard deviation of the birth weights of alpine goats is 1.36 kilograms. Now, I just mentioned that we're not collecting data from an entire population of all of the goats. So the population standard deviation typically would not be known to us because we don't have data from a population. But that's why it says assume at the front. So we're going to need to have a value for population standard deviation in order to continue this process. All right, so that's the assume part there. And then based on our sample, we will construct a 90% confidence interval for the population mean of the birth weights for all the alpine goats. All right, so this is an example from Alex where you'll hit a button to take your own sample and everybody would get different results. So these are my results. So 35 goats were sampled, and then they give me sample mean, sample standard deviation, and population standard deviation, and we'll use this information to step through the following. So let's start with sample size. Now I am going to include all the symbols here as we go through these. So 35 goats. So that would be our lowercase n. 35 goats were sampled. Now, point estimate, so you do need to know your vocabulary. So if we're estimating mu, the population mean, the best point estimate is X bar. So X bar, the sample mean, and that came out to be 2.37. So that's your point estimate for mu, population mean. All right, and then population standard deviation. Now, first, I'm just going to make a note here that for the 35 goats, this was the sample standard deviation. So we haven't worked with that in a bit, but we need to know that symbol. That would be S. So lowercase s is standard deviation of a sample. So that was just for those 35 goats. But we're assuming we know that if we did collect data from the whole population, the population standard deviation would be 1.36. So that's your sigma. So population standard deviation is 1.36. And then the critical value for a 90% confidence interval. So critical value, that's your Z alpha over 2. And we just did that one. It's still on my calculator over there. 3 places was 1.645. All right, so next we're going to step through creating the confidence interval. And the computer actually calculated some values here, but we're going to step through these ourselves. So standard error. So the standard error is the standard deviation of the sampling distribution. So this was our central limit theorem from the last chapter. So the standard error of the mean is sigma divided by the square root of n. So the process here involves applying the central limit theorem. All right, so sigma was 1.36 and dividing that by the square root of our sample size. And we'll go ahead and do that on our calculator and just confirm that we're matching the computer answer there. So 1.36 divided by square root of 35. They rounded to 2 places, so 0.23 looks good. So we're matching their answer there. All right, so then in our confidence interval, we're going to calculate our margin of error. So E. All right, so the formula is your critical value, Z alpha over 2, and that gets multiplied by your standard error. All right, so now we're calculating this by hand. So our Z alpha over 2, 1.645. And we already did our sigma over the square root of n. It came out to be 0.23. So 1.645 on our calculator there times 0.23. And again, they rounded here 2 places, so that's good. We're matching there. So 0.38. So when you do this question on Alex, you're not going to have to step through these calculations. We are doing it the first time through, so we know where these numbers are coming from. And then they give you their 90% confidence interval. All right, so they've written their interval in the form mu equals their point estimate, 2.37, plus or minus the margin of error. All right, so we are going to write this in the second form and then also graph it. All right, so let's find our lower limit. So we'll take our 2.37 and subtract our margin of error. And for the upper limit, we'll take our point estimate, 2.37, and add our margin of error. All right, 2.37 minus 0.38 is 1.99. And 2.37 plus 0.38 is 2.75. So let me write our interval in the second form. So we say lower limit, and then less than mu, the population mean, and then our upper limit, 2.75. All right, so let me finish the sentence here. So we are 90% confident that the population mean birth weight for all alpine goats is somewhere between 1.99, and the units up there were kilograms, 1.99 kilograms and 2.75 kilograms. All right, so let's graph it. So it doesn't have to be perfect here. Lower limit 1.99, upper limit 2.75. And then our point estimate is in the center of the interval. So that was 2.37, just approximate there. So 2.37 was our sample mean. And we had our lower limit and our upper limit. All right, so follow-up question now. So this is what we think. We think that mu is between those two values, and we're 90% confident. So now it says, does the confidence interval constructed contradict the publisher's claim? So going back to the start, the agriculture publication claimed that the population mean for all the alpine goats is 2.49 kilograms. All right, so let's see where their claim is on our number line. So 2.49 be about here. So this is the publisher's claim. So they claimed that mu was 2.49. All right, so we think mu is between 1.99 and 2.75, and the publisher's claim is inside of our interval, our range of plausible values for mu. So we don't have a contradiction going on because their claim is inside of our interval. So the confidence interval does not contradict the publisher's claim because their claim falls inside of our interval. So if their claim were not inside our interval, maybe somewhere over here, then we'd have a contradiction going on. All right, and then last thing we'll do here. So creating the confidence interval by hand, the calculations aren't that involved, but they take a little time. So we're going to now move forward and show you how to get that answer using our built-in ZInterval on the calculator. So let's go back to Stat, Tests, and pick our ZInterval. All right, and now for the sigma for our goats here, sigma was 1.36. The sample mean, our point estimate, was 2.37. Our sample size, 35 goats. And then 90% confident, and calculate. All right, so rather than the by hand calculations, we can just read there that first value, the lower limit, 1.99, and then the upper limit, 2.75. So the calculator writes the confidence interval in what's called interval notation. So in parentheses, lower limit, upper limit. But when we write our confidence intervals, we're going to remember to put in the parameter that we are actually estimating. All right, and of course, more examples to come.